Next, we will learn about the operating system. In the previous part, we learned that the operating system is the system software acting as an intermediary between hardware and users. But what exactly are the components inside an operating system, and how does it work? Now, we will look at the architecture of an operating system to better understand the relationship between hardware, the OS kernel, and application software. The first and most important component of the operating system is the kernel. The kernel is the core part that interacts directly with the hardware. It is responsible for managing resources such as the CPU, memory, and peripheral devices, ensuring that applications are allocated resources efficiently. On top of the operating system are application programs. These are the specific tools that serve user needs: Word, Excel, Chrome, Photoshop, games, and so on. Example: when you click Print in Word, the application sends the request to the OS. The kernel controls the printer, hardware, to execute the command. Let's look at the diagram on the slide. At the bottom is the hardware, CPU, memory, and devices. The kernel sits just above, managing and coordinating everything. The operating system, OS, includes the kernel and other system tools. On top are the application programs, where users directly interact. In the previous slide, we saw the architecture of the operating system, with the kernel at the center of the coordination between hardware and software. So specifically, what tasks does the operating system take? Remember, the operating system is like a master manager of the entire computer system. We will go through its main functions in turn. First of all, the operating system is responsible for managing all hardware resources: CPU, RAM, hard drives, peripherals. The operating system also provides a user interface, which makes it easy for us to interact with the computer. The operating system manages RAM memory. Data is temporarily stored in memory, and which data must be transferred to the hard drive. If the memory is not enough, the operating system also uses paging or virtual memory techniques to simulate more memory. The operating system divides the processing time of the CPU for processes. It ensures applications are rotated execution. It gives users the feeling that the computer runs parallel many programs at the same time, while in fact the CPU only processes one after the other very quickly. The operating system is responsible for organizing, storing, and retrieving files. We have just learned about the main function of the operating system, including a very important task: hardware management. But there's a problem. Software and hardware speak two different languages. How does the operating system understand what the hardware needs, and conversely the hardware understands the requirements of the software? The answer lies in the control software. Driver. The operating system manages the hardware not directly, but through the control software, device driver. Drivers are a special type of software. It's like an interpreter, helping the operating system and hardware understand each other. For example, when you click the print button on Word, Word sends a command to the operating system. The operating system calls the printer's driver, which translates that command to a language that the printer understands, and finally the printer works. Drivers are the bridge between software and hardware. Without drivers, the operating system won't know how to communicate with the device. Drivers are usually provided by the hardware manufacturer. When you buy a new printer and plug it into your computer, it sometimes requires a driver to be installed. If the driver is missing, the printer cannot work. Similarly, a graphics card (GPU) that wants to run games needs the right drivers to optimize performance. In the previous part, we learned that drivers are the bridge between the operating system and hardware. But drivers don't just appear on their own. We need to know how to install, update, and remove drivers. In this slide, we will explore how Windows manages drivers, since it is the most widely used operating system today. First is the driver installation process. Normally, when you plug in a new device, Windows automatically detects it and installs a built-in driver from its system database. If Windows cannot install the driver automatically, we need to do it manually, downloading the driver directly from the manufacturer's website. Next is updating drivers. This is very important because in some cases, we also need to uninstall or disable drivers. On the slide, you can see the device manager interface in Windows. This tool manages all system drivers. During computer use, you will likely encounter situations where hardware devices do not function correctly. For example, a mouse not responding, a printer not printing, or a graphics card malfunctioning. In such cases, the first thing you should think about is checking the driver. Since drivers are the bridge between hardware and the operating system, most hardware problems are related to them. The first possible cause is driver incompatibility. This happens when the driver is either too old or too new for the version of the operating system you are using. Example: you install Windows 11 but use a driver designed for Windows 7. Chances are it will not run properly. The second issue is driver conflicts. This occurs when multiple drivers compete for system resources or try to control the same type of hardware. Example: installing two drivers for the same network card, or some third-party software automatically adding a driver, which can confuse the system. The third case is corrupted drivers. This may result from incomplete installation or system errors during updates. When a driver is corrupted, the hardware may not function correctly, and it can even cause the computer to freeze or boot slowly. The solution is to uninstall the old driver and reinstall a new one from a reliable source. System monitoring: we keep track of how the computer uses its resources, including the CPU, RAM, disk, and network. For example, if the CPU is always running at 90%, the system may be overloaded. If the disk is too slow, it can delay file access. Monitoring helps detect these bottlenecks early. System cleanup: over time, the computer collects temporary files, cache, and other unnecessary data. These take up valuable disk space and may slow down performance. For instance, clearing browser cache or deleting old installation files can free several gigabytes of space. Boot optimization: when too many applications start at the same time as the system, it increases boot time. By reducing unnecessary startup items, like disabling auto launch for chat apps or media players, the computer can reach the desktop much faster. Startup optimization: even after booting, background programs may slow down the system. Optimizing startup ensures only essential apps run, improving both speed and responsiveness. For example, keeping only antivirus software active at startup while turning off others. On the slide, you can see the process and memory management screens of the Windows operating system. Process management allows us to see which processes or programs are running and how much CPU, RAM, and other resources each program consumes. Memory management screen shows information about internal memory, RAM, external memory, CPU, and GPU usage. To access these two screens, right-click on the taskbar and select Task Manager.